want to introduce Steve Rumrill. He's the Shellfish Program Leader for ODFW, and he'll be talking about the only native oyster to the North American West Coast, the Olympia Oyster.
All right, great. Thank you very much. Well, before I get started, I want to thank you all for all the great work that you do. I've been a resident of the Oregon coast for about 35 years, 20 years down in Coos Bay, and the last 15 or so up here. And it's a great admiration that I've become a resident of the Central Coast and been able to see all this great work. So I'm stoked. Yeah, thanks very much. All right. I'm also happy, and I guess I'm going to channel Evan here and do a lot of pointing.
There you go.
Today. But I'm excited and really happy to talk about a really neat project, a small scale pilot project, but an exciting one. So I'll be chatting about enhancement of the Olympia oyster population here in Yaquina Bay. So first of all, I'm Steve Rumrill, and my job, I'm the Shellfish Program Coordinator for the Oregon Department of Fish and Wildlife. I've got a diverse portfolio of duties to monitor and manage the commercial and recreational shellfish for the statewide. And that includes, of course, the bay clams, and razor clams that we're used to picking up. But I also have responsibility for the recreational Dungeness crab and red rock crab harvests, as well as a big multi-million-dollar pink shrimp fishery, abalone, urchins. It's a very diverse series of fisheries that I'm managing. As we think about that, I want to just raise up that I'm a little bit frazzled, so I ask for your sympathy today. And this is just typical for what's happened.
We're having some technical stuff we're working through here, so.
As we pull this back up, we're in the closing stages of a 2-week oil spill along the coast. And I've been the lead for ODFW in the wildlife section. So I've really admire all the folks that have worked very hard to protect and take good stock of the Oregon coast. There have been close to 75 or 80 people working to watch out for the Oregon coast here. At the same time, we're right in the middle of an unprecedented marine biotoxin event. You've probably seen those dealing with press releases with paralytic shellfish poisoning getting into our shellfish. All of these have landed on my lap over the last week and a half, and today's the high point of those last 2 weeks. Okay. So this photograph, I like this photograph. I'm kind of a 60s, 70s retro guy, and this has got laser beams coming out of my eye. I like to think to the future and imagine what kind of things could be. And what better person to work with than a young, talented student. I'm looking at the smiling face of Paul here as well. I had the great pleasure of working with Paul's son as one of his advisors in his PhD. And he was a great pleasure to work with as well. Very forward-thinking conservationist, careful scientist. My colleague in this project is Megan Considine, and another very forward-thinking, talented, smart woman from Oregon State University. And Megan, once we had a chance to work with her on her thesis, this project wasn't even her thesis. This was just a fun project to work together. But she moved ahead to join the Nature Conservancy. And she worked on behalf of Oregon to look at the conservation ecology of kelps and seaweeds here. And then she was selected as the global conservation aquaculture for the Nature Conservancy. Wonderful job. Direct connection from us working with her there. And she should be here giving this talk rather than me. Unfortunately, she lives in Puerto Rico. Okay, so I'm going to speak about this, and I want to acknowledge the funding. This is a very small project. It was about $25,000 grant from a wonderful organization, PMEP. It's way down here and blocked by the shadow. So PMEP is the Pacific Marine and Estuarine Fish Habitat Partnership. Fran Reck has been a great contributor to that program for all these years and a wonderful colleague. We're going to miss her when she's retired as well. But anyways, that's a small grant project, but also we fund through PMEP restoration projects and assessment projects and little pilot projects like this. Okay, so I'm going to move ahead, see if I can handle the technology. Just forward, right? Yay. Okay. I'm going to pick up where my colleague and friend George Waldbusser, Professor Waldbusser, spoke with you last year, not that long ago, 6 months ago or so, about Olympia oysters. He gave a great science talk. I reviewed that to make sure I wasn't telling you any fibs. So I've just popped this up here to remind me about George. And George was contrasting some knowledge about the Pacific oysters, Crassostrea gigas, which are really a non-native species, native to Southeast Asia, but global aquaculture, very economically important species, including here in the Pacific Northwest and here as well. And contrasting that with our native, tiny, diminutive Olympia oyster, Ostrea lurida. That one is native to the Pacific Northwest, extending down the coast of California and even possibly into Mexico. Not quite sure on the genetics. That reminded me when I said that word genetics, I put up, we now have the mitochondrial DNA map for many oysters, and Ostrea lurida down there on the bottom, you can see is distantly related to the Pacific oysters, but these are two distinct species in different families, have some very different life histories. Okay, and in order to pick up where George left off, I brought his last slide. So I'm going to read just a few things. To wrap it up, Professor Waldbusser said this: there are many great efforts working on restoration. I'm going to describe one. Olympia oyster larvae appear to be much more resilient to ocean acidification than expected. I'm not going to talk about that. The environments that oysters live in are challenging and hard to quantify. Yes, and I'll touch on that at the very end here. The Olympia oysters in Yaquina Bay are growing and not dying, which is good. We do have a recovering population here. Olympia oysters probably cannot fill the market niche of other oysters. They're never going to make up that global aquaculture. And despite what may be resilience to climate change, slow growth of these larvae means that they're very susceptible to overharvesting. And that's really where I'm going to begin my talk. Okay, I don't want to touch that anymore. All right, so first of all, just a quick recap. Olympia oysters were native species here, and they were very abundant in the past. They were very patchy, but abundant. And in addition to providing food for indigenous peoples here, I love this painting on the side. You can see the Indians harvesting Olympia oysters from a boat there. I think that's Coos Bay. To me, that looks like Coos Bay. But anyways, they provided food for indigenous people, but their filtering also provided filtration of the water column and improved water quality that lets more light through, which is great for eelgrass and seaweeds. They also stabilize soft sediments by building these reefs that hold together and stop sediments from being resuspended. And they also provide complex niche habitats. So their heterogeneous reef structure provides great habitat for shrimp and amphipods and little fish and feeding areas for birds. They're really a very nice element in our natural ecosystems. Here's just a photograph. They also occur in the intertidal zone, but primarily down in subtidal zone. What we think is that multiple generations of oysters generate these clusters of non-living shell, but also living shell attached to them at the adult stage, the juvenile stage, and also at that microscopic post-larval stage that we don't know much about. Early on in the effort to rebuild and recover and enhance Olympia oyster populations, those of us who were in that world got together and we said, they've been over-harvested and declined to such an extent that we don't have any living, good examples. What is it that we're trying to restore? And that question, what are we trying to restore? What should be our target for restoration was such a compelling concept that scientists got together and the National Geographic funded an expedition. Go try to find an undisturbed Olympia oyster bed. And they did. They found some up off the coast of British Columbia. And those are stacked very deep, 4, 5, 6 inches of living oysters, stacked on top of about a foot of dead oysters and breaking them up. Very difficult for us to restore that, but we know that they just built these multi-generational heterogeneous reef structures. So that's a target that we would like to achieve, and we're a long ways from that. Okay, a little bit of history. So commercial oysters harvesting, there was a dramatic increase in the native oyster harvest in San Francisco in the 1850s, associated with the gold rush, really an insatiable demand fueled by the gold rush, and it outpaced the supply locally and began to reach up here to pull them back down as well to feed that demand. The California oyster populations, San Francisco Bay and Bodega Bay, rapidly declined due to overharvest, coupled with degradation of estuarine habitats due to building along those shorelines. The harvest here in Oregon and Washington then increased to meet that demand both internally but also externally. And harvesters migrated north here into Oysterville, right? Part of Yaquina Bay was locally known as Oysterville, right in prime oyster habitat. And oysters were barged out of here to San Francisco. Just some images here about those days. The harvest and habitat loss dramatically reduced the populations of native oysters throughout the Pacific Northwest, really by 1910. By 1910, 15, 1920, we were really concerned. It's written records just saying we've over-harvested here. We've got to really cut back. The graph on the right just shows commercial oyster harvest from 1890 to 2010. You can see those harvests and then really dropped off. And we're down to the point where they were almost functionally extinct. The first attempts at artificial propagation of native oysters began way back in the 1890s and didn't work out. And there were problems with habitat and also very slow growth. So then oyster aquaculture aficionados then began to transport other species into the Pacific Northwest. That included the eastern oyster from Chesapeake Bay, Pacific oyster from Japan, and those were not sustainable on their own. They needed aquaculture, hatcheries, a big input of work and energy to make those go. And the Pacific oyster is really the one that has worked out. Non-native oysters, I lost that off the bottom, but anyways, they end up being kind of a hanger-oner. In fact, the Pacific oysters that were reintroduced and found down in Coos Bay, when we analyzed the genetic signature, they were not native to Coos Bay. They had been imported from Washington. And moving oysters back and forth, Coos Bay got reestablished as hitchhikers, and oysters moved from Coos Bay down there. Okay, so Olympia oysters were historically an important component of the estuarine ecosystems of Oregon, and the populations were overharvested by the 1920s. They were harvested by native people and then by Western European settlers, but then they really became functionally extinct. So activities are underway to help rebuild the populations in Coos Bay, here in Yaquina Bay, and Netarts Bay. My colleague Scott Groth and I wrote a paper many years ago trying to figure out where were Olympia oysters here, and we found evidence in those 3 bays. They could have been elsewhere, but that's where we've concentrated our efforts so far. So the goal of this pilot project, this small enhancement project that I'm going to describe, was to enhance the existing population of Olympia oysters in the rocky intertidal habitat of Yaquina Bay. Keep in mind the subtidal is good habitat, but this project was focusing in on Yaquina Bay. Our specific objectives were to provide about 300 bags of living oysters or living oyster culch. That's tiny juveniles, living juveniles attached to a dead shell. That's culch. And that we were calculating contained about 3 million new larvae. So a pretty significant recruitment event. We were also, our objective was to install these artificial modular substrata that we named Olympia Oyster Havens as surface for oyster growth, but also to see if we could come up with some kind of protection against the non-native European green crab, which has invaded our estuaries. My colleague Derek came and spoke with you about that, gave you the whole fill-in. So we're concerned about the predation by those non-native crab that are increasing here, having an impact on our native Olympia oysters. And then we also wanted to provide complex habitat for diverse communities of fish, shrimp, amphipods, polychaete worms associated with these clusters that are going to grow, but also with our habitat. So just some quick pictures to think about Olympia oysters. Olympia oysters occur in these clusters, typically gluing themselves to each other or gluing themselves to hard substrata like rocks. In Coos Bay, we found a shopping cart that had been tossed off a bridge that was heavily colonized. Old logging cables colonized by Olympia oysters, an old motorcycle that somebody had ditched off the side. If there's hard substrata out there, they'll take it. They prefer landing on each other. And in fact, the Latin name here, Ostrea lurida, used to be Ostrea conchophylla, and conch loving or shell loving. They like other shell. That's how that used to be. Okay, so anyways, we have those of us who work in the intertidal zone or shallow subtidal have kind of these images of the oysters clumping together into these clusters, even though historically they would link together into much larger systems we hope to achieve that sometime in the future. The problem working in the bays and estuaries is that there's been a tremendous loss of suitable hard substrata. And now we have systems that are really dominated by soft sediments. The reef structure, a lot of the rocks and gravel, and the shell is really covered now in mud or has been pulled out through dredging and filling. So a picture of Netarts Bay here, my colleague with the Nature Conservancy, Dick Vanderschaft, many of you probably know him. So he worked to try to assemble a small oyster bed right on the interface between eelgrass and subtidal channel. He kept that fight up for a long time. It got sedimented in. It just didn't have enough oomph to it. Here over in Tamales Bay, my colleagues there, you can see them doing some interesting kind of humped up structures down on the bottom. Those are created out of concrete, and then also even stakes out there to just raise them up, trying to get out of the sediment situation. Well, what about here in Yaquina Bay? We certainly have areas like that, but this project, we were facing this issue. Could we build some clusters and enhance the clusters at an existing site? So we picked the Coquille Point site. Coquille Point is right there at the south end of Sally's Bend, and it's a very interesting transition from the very soft muds up in Sally's Bend to then a semi-lagoonal. I don't quite know its history of rocks in the intertidal zone there. But anyways, that's the most oceanward, most seaward extent of our native Olympia oysters right there at that site. We know from the past that Olympia oysters that reside there and spawn there have sufficient time for their larvae to move around but not get completely flushed out of the bay. That's some good work done by OSU students in the past. But anyways, we picked that site as a promising site for this work. So Coquille Point, as I mentioned, is a weird kind of lagoonal rocky dike that's built out there. Here's what it looks like. So when you're out there at a good low tide, there's rocks and boulders and gravel that make up that site. And we know there are patchy clusters of oysters out there right now. And it's right on the edge of the eelgrass and then turns into soft sediment. Good site for Olympia oysters. Okay, just real quick, the life cycle of Olympia oysters. The adults are males and females, and the males will release their sperm freely into the water column. The female is a filter feeder and sucks that sperm back inside and fertilizes the eggs. Those eggs develop when they're fertilized into early embryos, and then they develop into the larval stage. And that larval stage is known as a veliger. This slide for now. But anyways, that veliger stage is really a microscopic clam, and it can swim, and it has a foot, and it's up and moving around. So petty means foot, and veliger is this type of mollusk larvae. So it's a swimming microscopic clam that can feed in the water column, but then also get down on the bottom and check things out. So they're wonderful. They use a ciliary band to swim and capture food. They use their muscular foot to attach to the bottom and move around. When they finally make a decision, and I want to call it the most important decision in their life, that I'm going to live right here, they attach to the bottom, cement themselves to the bottom, complete this metamorphosis, and really start to take up life as an attached organism right there at that spot. Can you imagine making that decision when you're that young? This is going to be it forever. Okay, and then they grow up, they love to settle on other clams. That's a good signal that they're in good habitat, and then they'll grow up into an adult. All right, so what did we do? Megan and I got together and we worked with the Whiskey Creek Shellfish Hatchery and built this project. So we collected gravid adults here from Yaquina Bay from that site. And then we did, as we're supposed to do, and I'm in charge of, make sure that they're free from pests and diseases. They're not carrying bacteria or viruses or anything. So we got them tested to make sure that they were clean. Then we took them up to the Whiskey Creek Shellfish Hatchery, and the wizards up there, up in Netarts Bay, did their magic, spawned them, raised the larvae, cultivated them, fed the larvae, got them all ready to go, and then settled them out onto these shell bags. So we had 300 shell bags just sitting out there waiting, and then when the time was right, we put those in the tanks. Larvae settled all over those, and then our job was move them down here and get them into Yaquina Bay quickly. So what we did, we had 300 bags of culch. We did the calculation quick. that's 7,500 pounds. Like, how much can you carry in a U-Haul truck? All right, so we got them into U-Haul truck. We were right on the edge of what we did there. And the concept there was put big tarps in there and as much ice as I could pack in, just make a big burrito and drive down here real quick. So we drove the 75 miles down here real fast. And Megan organized an army of graduate students to help us get them in the water. So that's what we did. That was the plan and it worked fabulous. All right. So graduate students and my staff here, Mo Bancroft and Summer were working with me, and Megan got her friends and colleagues there, and that was our job, get them out of the U-Haul truck and out into the water ASAP. It worked pretty well. It was a lot of fun. So we got them all out there, and then I went out afterwards and moved them around and fussed and stuff like that. And enjoyed all of that kind of stuff on my own. So what we did here, just some photographs here. Trying to do good. I also took those adults. We didn't kill those adults. We brought them back and placed them back out into the field. So I released my broodstock back into Yaquina Bay. Every time I go there, I look and see my adult oysters. So there they are. And the bags then I arranged on that line, long line, right at the interface between the rocks and the eelgrass, right in that site. Okay, so then I've been keeping tabs. I haven't updated this, but we did that work back in August of 2021. That's when the larvae settled out and took up life on the bottom. The density there was about 30 per shell at that point, and that's my time zero for measuring survivorship. And these were tiny little oysters. As we move through, you can see how the numbers went from 30 to 26 to 18, 15 per shell, 8, 6, 5, 4, mortality. Okay, they're dying. They're living for 3 years and they had a lifespan about that, but the density goes downhill. These are unprotected. I cut and opened the shells. Where did I do that? I think I did that in July of 2022. Can't quite see it on the bottom. Can we get rid of that off the bottom? Anyway, so I cut the bags and let all the oysters out, freed the babies, and kept track of the size as they grew. Thank you very much. Yeah, so at the bottom, the oysters were released from the mesh bags in July of 2022. And I put the circles around March and July of 2023, because at that point, I began to see new recruits. I didn't put those juveniles, that 10.4, the 15.6. Those are natural oysters now coming and recruiting back in to our systems. So it was good. We've created some habitat and we're able to provide habitat for new oysters coming in. So here's just a graphic that shows that over time, the juveniles, that blue line, just shows the growth and progression of the juveniles that were raised in the hatchery and then brought down here as they grew up into juveniles and then progressed into larger adults. And then the orange line shows the juveniles that recruited naturally from Yaquina Bay back onto those sites. So we've created habitat for at least 2 generations. Next time I go out there here, probably in July, I hope to find a 3rd generation there coming in at that site. Now, the decline, 87% over 23 months, that's a lot. They suffer a lot of mortality, not only to the elements, to being smothered by soft sediment, predation by crab, there are predatory snails out there, lots of things that are going after them. But this is in that kind of natural situation. All right, so 13% survival over 2 years, modest rate of growth. And then we found that exciting point, recruitment into our oyster havens in September of 2022. So let's look at those things. So this was really where it was a pleasure to work with Megan. She did great on all the other logistics, but she was really interested in this biomimicry. And she's interested in that for corals, for seaweeds, for oysters here, salt marshes. And a quote when she was doing a radio interview here, instead of using simple and smooth breakwater structures or seawalls, we can try to incorporate textures and shapes that are designed for specific organisms. Another quote, we're working with nature rather than against. For instance, if the goal is oyster settlement, then we try to use appropriate textures, such as crevices and cracks and pits. And the designs can also be used for hard substrate for coral outplants or for this oyster restoration effort like this project. Let's look at that. Megan engaged, do you know this guy? Alex Schofield is a professor at College of Arts and Objects and Ideograms down in San Francisco. We reached out to him. He does some very innovative work, thinking about different structures in the marine terrestrial environment, different composition and such. Just a few of the examples here of really interesting shapes and things that he's built and then deployed into San Francisco Bay. It was a pleasure working with him and thinking about these problems. So we got together and we provided Alex with the same kind of pictures that I just shared with you about the clusters of oysters, the substrata, the size of the boulders out at Coquille Point. And he put his thinking cap on and designed these durable angular panels that were designed to be placed among the boulders. I was also letting him know about the salt sediment and seeing if we could build up sediment and build some topographic relief. And then finally, one of our overall goals, build something that might protect these Olympia oysters from predation by green crab. So they were trying to mimic the rough surfaces and heterogeneous substrata. They needed to have low hydrodynamic drag to resist the movement of our substantial currents. They had to have some interior spaces that might perhaps work as refugia against predation by crab. And then we went to work. So he came up with the materials and built these molds. And then we assembled them here over at the Hatfield Marine Science Center, fabricated 36 modules from a mix of magnesium oxide with pulverized basalt. And see how they'd work. Initial recipe wasn't good. They dissolved, so we had to go through that. But here's what they look like. So the Olympia Oyster havens, they were modules that were about 15 to 30 centimeter footprint, kind of about the size of the tiles that you put. They have raised relief with mounds and holes and ridges and troughs and pits. Some neat creativity there. The angular panels could be arranged into larger planar structures. Could put 5 or 6 of them together or just 2, depending on where they fit. They're lightweight and durable. Some very interesting panels there. I can go back. When we were looking at them, they had these kind of weird volcano structures. And he said, well, that's just in Oregon. That's like Mount Hood for you there. Turned out they were neat. Okay, so these modular panels could be placed around boulders. There's Megan placing them there in that kind of situation. You can see how that works. And they're protected. We put some boulders on them to kind of stop them from moving as well. But very neat design here, unique to the spot. So as we're keeping tabs on the growth and survivorship of the Olympia oysters on Culch, we're just measuring them with conventional calipers. You can see a pretty big one here, 30.2 millimeters or so. But this is an Olympia oyster here that's growing on top of a shell. That's one of those that we cultivated and placed and put out there. But as we worked with the panels and took a look at them, and I brought them back in, cleaned it up, and I was careful to not disturb the growing animals on here. Looked on the outside, covered with sediment, but you flip it back over, and there it's settled with barnacles and other organisms. Look very closely at those, and there we have Olympia oysters that have settled on the inside of the volcano. That's a good spot for them. They like to be out of the water in the darkness in a good place where it was not covered by sediment. So inside we've got all the oysters, the new recruits, that second generation, coupled with barnacles and mussels, a nudibranch that is picking on one of the mussels in there. So here it is, just pointing that out. You can see these really very small Olympia oysters that have attached in and just started up a community protected inside that little volcano. Excited to see that. So back here, so that's these little orange juveniles, that second generation. Now we really want to know, do these artificial havens actually provide a refuge from predation by the European green crab? And that I don't know the answer. We're going to continue to go out and look at that and maybe do some lab work where we can keep track of what's going on there. I won't talk about this very much because my colleague already spoke with you about the invasion of the West Coast by these non-native green crab, but they do pose a threat to our native Olympia oysters as well as to juvenile Dungeness crab and red rock crab and other species. So they're aggressive predators that feed on clams and oysters, and they're increasing in abundance. Our team is doing what we can to monitor their abundance. Just a quick a refresher here, there are some identification issues, people misidentify them. So we placed a limit on the recreational take at 35 crabs per person per day. And I'm comfortable raising that to a higher level when the communities can show us that they can recognize properly this species. It's easy to recognize that it's got 3 bumps between the eyes and 5 down along the other side, but their color is quite variable. They can be red or orange or yellow. It's kind of a misnomer to call them European green crab. They're originally from Europe, but they're not always green. So we're working on that. And they're aggressive predators, so I won't go into that, but some difficulties there as they swept up and down. So the oyster aficionados and practitioners are very interested in coming up with some sort of way in many of these bays and estuaries that are invaded by green crab now, that also some of them have Olympia oysters. Can we come up with some kind of way to protect our oysters and give them a refuge, in addition to perhaps really, trapping and removing large numbers? The aggressive trapping and complete removal is very difficult. Here in Oregon, we are looking to our colleagues up north who are spending millions of dollars in a trapping effort that may or may not be successful. We look down to our colleagues in California who also spent a large amount of money. When they stopped, the numbers of green crab in space went up 30 times. So it's not going to be a one-time removal of an invasive species. It's going to have to be a long-term. So we're working with the Oregon Invasive Species Council right now under the great guidance of Professor Kat D. Rivera, world expert on green crab. We're fortunate to have her here to work on and develop our management plan for this species, and then get that approved through Oregon Invasive Species Council before we figure out what action we're going to take. Okay, so I won't go into that anymore. We're monitoring in the areas here that Mitch talked about. So my final thoughts here. We put out about 3 million new post-metamorphic Olympia oysters into the intertidal zone at Coquille Point here in Yaquina Bay. That enhancement effort, we think, resulted in the addition of about 300,000 to 350,000 adults after 2 years with that great mortality. The shell rubble living oysters, of course, provide a complex 3-dimensional habitat for the fishes, crab, amphipods, and worms while that mortality was going on. So that was a lot of shell material. Our artificial oyster havens were selected as sites for settlement by the wild stock Olympia oyster. We're stoked about that. And these modular oyster havens were successful, and they might provide some kind of possible refuge from predation by European green crab. We still need to do more follow-up work to see if that's true. So next steps to complete the monitoring in 2023, 2024, periodically getting out and cleaning those. And I still have on my workload, I have to put up an interpretive sign out there to explain that project. So I think with that, I'll stop here. Is that okay?
A little time for questions, and you could just repeat the questions so
Sure.
folks on Zoom can hear it.
Apologize for my voice coming out, but all right.
Any questions?
Oh,
You haven't mentioned blue carbon.
yes.
And the potential for this effort to be linked to that. Historically, when you look back in time, the sheer volume is kind of mind-boggling.
Yes.
What was extracted,
Yes.
and we're at this really remnant population. Could you talk about that a little bit?
Sure. So blue carbon really is, pulling atmospheric CO2. Oh, ask your question. Yeah. So the question is, how does the enhancement of oysters and the historic degradation and loss of oysters out of these systems, how does that relate to our current thinking and understanding about blue carbon? Yeah, so blue carbon really is pulling atmospheric CO2 into structures in the marine world for the blue carbon side. That could be oysters, could be kelps and seaweeds, could be other organisms that pull that down, salt marshes, eelgrass as well, pull this back down. To what extent do the oysters contribute to that? We think substantially. There's some debate about that because building the shell has a lot of biochemical twists and turns that I don't completely understand, but anyways, you can tell it just would pull in quite a bit of calcium carbonate into these long-term structures that would be there for many years. They'll break down over time and release some of that material, but it's just hard to imagine that the mass of shells that were likely here were probably a great contributor for long-term storage in those sediments. The other issue is that this complex three-dimensional structure also traps a lot of organic material. It's a good place for polychaetes and amphipods to feed and capture food. So all of that organic material that's trapped in this three-dimensional structure may also figure into the blue carbon budgets. They're under development here in Oregon. We've made some good progress, but I don't think that our blue carbon estimators so far have considered this element. Yeah, great question.
So on the front end, you mentioned oil spill and the crab issue.
Yes.
And I just had the crab cake for lunch today. And, is that okay?
Yes, so the question is about.
And then what kind of crab is that? Is that one of the bad crabs?
Yes.
That I have?
I can assure you a question about how safe are the crab to eat today?
Yeah.
Okay,
Okay.
yes, and in the crab situation, we have multiple biotoxins. The domoic acid is the one that we typically think about, and that's the one that really gets into crab. The ongoing shellfish biotoxin event is paralytic shellfish poisoning, totally different toxin. Yeah.
The photo you showed of Netarts Bay and Coos Bay, I think, no, Tomales Bay.
Yes.
Showed the loss of hard structure and how key that is to being able to restore. What was the hard structure? Was it old oyster reefs? And is there an accelerated sedimentation going on because of human activities?
Yes, question is looking at what are some of the reasons why we have lost our hard substrata in our bays and estuaries here. And a lot of different reasons. As you've pointed out, we've lost, complex gravel, living oyster reefs that could keep up with a low level of sedimentation, coupled with, overharvesting of trees in the watersheds, which has allowed a lot of sediment to come through. Dredging and filling has taken away some of that fringing habitat. Loss of eelgrass is another contributor here. The loss of the tidal wetlands, which would have filtered a lot of that material. The loss of eelgrass, salt marshes. So we've just really loaded the systems up. Now, estuaries generally do fill up with sediment, but with all of those other bioactive fringing elements around, that would have slowed that down quite a bit. Yeah. Is that right? Here's the estuary experts right here.
Yeah, this may have been mentioned earlier, but were Olympia oysters completely extinct in the Yaquina before they were brought back down to Washington?
No, so I was trying to be careful and use that term, functionally extinct. So there was a tiny little remnant population here. Yes.
Can you tell me, you remember which part of the bay that remnant population is from?
Yeah, so great question. So the question's about where did the remnant populations here in Yaquina Bay fit? I can just describe really quick. Just yesterday, another of my students, Marlena, just defended her thesis looking at spatial variability in the success, the growth rates, and survivorship. And earlier, we know that Olympia oysters were occurring in Oysterville, right in the middle near here, Bull Slough and near the oyster farm. And then I described the area up there north of SL, Sawyer's Landing, or Coquille Point. The remnant populations are very good in that middle zone. Upriver towards Toledo, there's a barge that's right on the edge. That's the most upriver Olympia oyster I can find, lives on the barge. Yeah. Anyways, in that middle mesohaline zone, Marlena transplanted oysters out at the Hatfield Marine Science Center, and they live there too. They aren't there naturally, but they can tolerate the higher marine dominated waters there. But she was looking at the success, and they're at Kings Slough, Sawyer's Landing, Coquille Point. That's where we found the greatest success. So as we move forward and think about some larger scale, perhaps Olympia oyster work, Silet's tribe has worked down in that Bull Slough area, middle zone. They've had some successes there. We've had good successes further up, but it'll likely be in that mid zone there. There's a lot of riprap along the side, which is good habitat right now too. So some sort of way to enhance that would be helpful. Great. Ryan.
Are there opportunities to scale up your reintroduction program not just in the Yaquina estuary, but systemically up and down the west coast?
Yes, I don't have time to talk about that, but I ask you to invite me back. So I'm in cahoots with my colleagues in Alaska and British Columbia, all the way down to Mexico. And we published a couple papers looking at conservation, aquaculture, trying to figure out the proper location and tidal height. And so I've contributed the data from this Coquille Point into the big meta-analysis, trying to figure out where in the intertidal zone from the deep to the uppermost limits, should we build these little reefs? So far, we've been all kind of doing it by the seat of our pants on what we think is best, but this big analysis will help. And we were just chatting earlier about an Oregon coast-wide multi-estuary project that I'd be happy to work with you all. Yeah. Thanks,
We know, we've got problems in the watershed as a whole, all of our systems.
Yes,
And sediment, fine sediment is one of the factors, and so that actually plays out as something that we restore uplands, and the watershed uplands will help in the estuary.
yes.
The other piece of the story is the estuary is on the 303D list as impaired. Have they established those thresholds for, like they have for salmon, fry, spawning, all those are thresholds designated? Do they have that for the oysters, as an example?
No, yes, so, question is, do we have thresholds for impairment to recognize when water quality becomes a limit for Olympia oysters? No, we don't have that at this point. We do have some good work looking at physiological, tolerances in temperature and salinity. I'm not aware of any technical literature that look at suspended sediment load as an impairment to growth or survivorship. I don't think that work has happened at the lab level. And at this point, our native Olympia oysters here are on the Oregon Department of Fish and Wildlife nearshore conservation strategy as a species of greatest conservation need. So that's really our status there. And then I can just share with you, as long as I'm in charge of shellfish, I won't allow recreational harvest until the populations, build back to a level where that could occur. But that's about what we are.
Well, the effort to deal with the near shore and kind of like establishing bioindicators. If natural species can make it and establish it, it's a big deal with OA.
Yeah.
And so we've had George Wallbuster here talking about his project, and it's really awesome. I feel we're fortunate to have, research going on just by chance in the estuaries that we're working, trying to protect and restore. It really is a great partnership from my perspective.
Yeah.
We really appreciate all the work that you guys are doing.
Okay, well, thank you very much. Paul just said we're doing great.
Any questions on Zoom?
Yeah, Mo mentioned that he thought that the large wooden boat that was hauled out to Yaquina Bay might have been an old Olympia oyster barge. Did you know anything about that?
No, I didn't. This is Mo Bancroft said that? Oh, he used to work for me. He should have told me that. He set me up, that guy. No, I didn't. I don't know. That'd be great though. That's interesting if that's the case.
I'm sorry, I'm not familiar with the terms in the methodology, but Historical Society here, we have a collection of postcards, and some postcards have rock oyster hunting and night beach. And night beach is not tidal. And is that kind of a similar oyster or totally different?
Totally different species, yes. So the rock oysters, I think, that are in those historic photographs are piddock clams. You know that term? So those are clams that burrow into the soft sandstone and mudstone. And they were typically harvested by pulling the rock apart every once in a while. People still do that every once in a while, but I think that's what's being referred to as rock oysters. Yeah.
Last question?
All right, thank you very much.
Thanks.
Thank you very much.
Short little 5-minute break. Thank you everybody for coming. Stick around, board members.
And thank you, Steve.
Sure.
One more time. Thanks, Steve.